This conference will now be recorded.
So in the last class, we discussed about what is a Kubernetes cluster and how a Kubernetes cluster work and why do you need a Kubernetes cluster and what is the purpose. All these things we had an overview. And Kubernetes is basically it is a product. It was a product of Google. Google used this to manage their infrastructure, and later they made it an open source. And now it is a open source software, a free software that anyone in the world can use or contribute. And this software is capable to orchestrate your Docker containers. You can give the instructions to Kubernetes how you want your Docker containers to be created from the Docker images. So Kubernetes will take your Docker images and create containers in your production environment. That is what Kubernetes will do. And many things. You can instruct a lot, huge amount of configuration to Kubernetes, and Kubernetes would take that, right? And that is pretty much about Kubernetes. And then we started creating our own Kubernetes cluster. We discussed that. Monica, can you mute yourself? Okay. So then we talked about uh, Kubernetes has two type of components. Kubernetes, you can say it is a combination of multiple software, right? Multiple software put together would form, the entire Kubernetes infrastructure. And the main, it can be classified into worker and manager. Worker is nothing but the machines where you will create your containers. Your company have a number of Docker image, and from that image you want to create a number of containers, or in other words, you want to run your software, you want to run your workload. So all these containers will run inside the worker nodes. Then the manager node, we use it for running some management softwares. So manager is the core component of the Kubernetes cluster. It can, it is the one who will take the instructions from you, what image to be used, which containers to be created, how many containers to be created, right? All this information, it will be the master who will master or manager who will gather all that information and get things done. So that is what a Kubernetes cluster is. And yesterday we created a cluster, right? By running the kubadmin init command, we created our own cluster. And if you remember, we ran the kubadmin init command only on the manager node. So right now, we created a cluster, but only the manager node is a member of the cluster. Now we need to add other nodes as a member to the cluster. So let us start. So today's agenda is add worker nodes to the cluster, and later on we will start with the concepts, few concepts of uh, containers and pods, and then we will talk about deployments in Kubernetes. How do you run the containers in Kubernetes? How do you set up the YAML files? All those things we will discuss, and then we will talk about your software, how you will make it available to the other people or other software components. Basically, shopping cart want to connect to Prime customer, or people from outside world want to connect to the front end software using their browser. So how can containers be reached from outside or within the Kubernetes cluster? How you can connect to the containers? That we will discuss when we learn service. And right, these are the topics we are going to discuss today. Yeah, it is being recorded. Okay, so let us start. Let me log in. Let me log into all the three machines, the manager and two workers. This is the manager. And here you have the worker one. And then you have the worker two. So I'm going to log into all the machines. And what we did yesterday is we executed this command kubadmin init. Kubadmin init is the command we executed yesterday on the manager machine. This machine that I am working, we already executed the kubadmin init command. Now there is a cluster already. You already created a cluster. So we already created a cluster using kubadmin init command. And if you want to see the list of Docker host, right, or list of machines in the cluster, you can use this command kubectl get nodes. Oh wait, you cannot run the kubectl command yet. There is something you must do first. First of all, before you run the kubectl command, I already told you the kubectl is capable to connect to the cluster and do something in the cluster, right? If you want to create a container or delete a container, if you want to see the list of container, if you want to see the list of Docker host in the cluster, or nodes, I would say nodes. Nodes means machines, right? The EC2 machines or Docker host. The three machines that we created, they all are Docker host, or we generally in Kubernetes, they are referred as nodes or worker nodes, right? If I use the term node, that's what it means. So to get the list of nodes, you can execute this command kubectl get nodes. As I told you, to get nodes or get pods or to get whatever you want information from Kubernetes, kubectl is a command that will connect to your Kubernetes cluster and get that information for you. But before you run the kubectl command, there is a certificate that you need. The certificate is located at this location /etc Kubernetes admin.conf. So this is a certificate that would get generated automatically when you executed the kubadmin init command. And anybody who want to run the kubectl command, they must have this certificate. So currently in my case, I am logged in as the root user, and as I told you, anybody, you can copy this file to one of your engineer, and that engineer on his laptop, he can save this certificate, and then from his laptop he can connect to the cluster using the IP address of the cluster. So that is possible. So I'm not getting into that point right now. We will talk about that in detail later on. So for you, you need to understand, if you want to run the kubectl command, you need this file with you, and the file has to be located inside your current folder, a location called .kube. Then what was the file name? I think it is
config,
right? Config is the file name. Yeah. Okay, first I should create the .kube folder, and inside the .kube, I'm going to create a file. The file name should be correct. A folder name should be .kube within your home folder. So right now I am logged in as root. Then I am inside the /root folder, the home folder, and in that folder I created a .kube folder, and inside that .kube I must create a file with the name config, and that should be the file name. Remember, that should be the file name. You should copy the content of admin. So what I did is I used the cp command, which will make a copy of this file at this location. You want the certificate at this location, and if you want to take a look at that content, open that file in a nano editor, you can see there is a url to the cluster, there is some certificate, and you need this certificate if you want to run the kubectl command. And yes, now I can run the kubectl command. All I need to do is I should copy this file at this location. Now I am capable to run the kubectl command. I can run the command kubectl get nodes is a command. When you run this command, it would show you how many nodes or Docker host do you have in the cluster. Remember, we ran the kubadmin init command on the manager node, and currently there is only one machine in the cluster, the manager node. So the worker nodes I am yet to add them, which I will do. So for now, it is only one node in the cluster. It is a single node cluster right now. Okay, fine. So the next thing what I want to do is I want to all right. There is some token. If you remember, when I executed this command kubadmin init yesterday, what happened is a token got generated, and then it printed me one command. This is the command you can run on the slave machines. I got some command, with message saying that run this command on all the worker nodes if you want them to join the cluster, right? So, but right now I didn't copy that token. So you need a token if the worker nodes want to join the master node. So what I will do is I will create a new token. Yes, you can create a token whenever you want to. So using the kubadmin init kubadmin token create command, I believe that is the command. I can execute anytime I want on the manager node. Then a new token would get created, and using that token, my nodes can join the cluster. Currently, it's only the manager node. So let me give me 1 second. Let me look for that exact command. Create token. I want to create a token. Token create is the command. Token create is the command, and certificate key string groups description how the token is used. Okay. Print join command. Okay. If you use this option, it would also print you the join command. So I would run this command kubadmin token create. This command would create a token. This is the command that will create a new token. And if I used this option minus print join command, then I will be able to see the join command also. I mean, it will print you. This is the join command that worker node need to run to join the cluster. So run this command, and then what happened is a new token got created. This is the token, and this is the command the worker nodes. I already created 2 more machines in AWS, and I already installed Docker and kubadmin kubectl software in those machines. In those machines, I can simply execute this command, and they will join the cluster. So let me go to both the worker machines, and then I am going to execute this command in both the worker machines. We already installed kubadmin in both worker machines. All I need to do is just execute this command, and there is something that is pending. Actually, when the worker node execute this command, they will connect to the manager node on port 6443. So port 6443, must be open in the manager, because when worker node execute this command, it will try to connect to the manager node on port 6443. So before executing this command on both the workers, I will first open the port 80 in the security group. So let me do that. I will go to the AWS security group of, go to the manager, and in the security group, I would open 6443. I am adding a new rule to open 6443 port. Let's put anywhere. All right. So what we did is we allowed worker nodes to connect to the manager on port 6443, and now the worker nodes can execute this command. They can successfully connect to the manager on this port and with this token, and they will automatically get added to the cluster. I run the command on the first worker node. I'm running the same command on the second worker node as well. Then what happens is both worker node will get added to the cluster. Yeah, it is done. The first worker node is added to the cluster successfully, and the second worker node is also added to the cluster successfully. Now I go to the manager. The first tab is the manager. Let me name it manager. I go to the manager, and inside the manager, I'm going to execute this command kubectl get nodes. Now you can actually see there are total 3 worker nodes in the cluster. Right? It looks good, right? So this is the situation right now. We have three machines in the cluster. Just to confirm or just to demonstrate, what we did is we created a Kubernetes cluster yesterday, right? And there was only one machine, part of the Kubernetes cluster, the manager machine. This is where we executed the kubadmin init command. When you run kubadmin init, automatically this machine will become a cluster. I mean, a cluster get created, and this is the only machine who is a member of the cluster.
Basil, sorry to interrupt you. So to create the cluster, what are the commands we have used yesterday, Basil?
Can I finish this and then I can come back?
Yeah.
Just this topic. Then we also created 2 AWS machines to act as the worker nodes, and on the manager node we created a token. And because the worker node, when they want to join the cluster, they need a token, right? That is why we created a token in the master. My plan is to make them worker nodes, right? These are the worker nodes I'm planning to create. I planned to create. Now they are already member of the cluster. So before running the kubectl command, I copied the certificate in the correct path. It must be done, right? Then only you can run the kubectl command. Kubectl get nodes is a Kubernetes command that would actually show you all the nodes in the cluster. And right now there was only one, and now we want both of these AWS machines where we already installed kubadmin and Docker yesterday. You want them to connect to the master, and the master node will add them to the cluster. So this is what we wanted to do, and yeah, it is done. Now it is done. By running the kubadmin join command, both of these worker nodes join the cluster. Now your cluster have total 3 nodes. One is the manager, 2 are the workers. And remember, we always create our containers in the worker nodes. We won't directly create them. We tell Kubernetes components running inside the master what it should be. I mean, you will give these instructions, right? You will create the instructions, and the manager node will read this instruction, whatever you provided in the form of YAML file, and based on that, it would create containers in the worker nodes. That is what it will do later, and that is exactly what we are going to discuss next. But actually, there is something that we missed. I will talk about it. Something I wanted to, I forgot to discuss. I will talk about it. So before we go to that topic, can anyone any questions?
Hello, Basil. Uh,
Yeah.
so, this is regarding the security group related question. What is inbound rules and what are the inbound rules and outbound rules?
Inbound rules are incoming connection to your AWS machine. Who can connect to your AWS machine?
Okay.
With respect to AWS machine, it's inbound. Yeah.
Then
Um,
the 6443 port number, what will it will do, Basil?
6443 port number will basically be used by the worker nodes when you executed the join command on the worker node. Worker node want to request manager node to add them, right? So the worker node first want to connect to the manager. It connects on 43 port, and then it will ask manager, this is my token, please add me, and then manager will add them. So basically 6443 is a port that is used for communication from the worker node to the master. So the port must be open. That is why I opened it.
So we opened on worker machines or manager machine, Basil?
It is the manager machine who will get connected.
Okay.
Worker machine will connect to the manager, so port must be open in the manager.
Okay, Basil.
This is one question. The manager, I saw the IP is not the public IP, but the internal LAN IP, which is 172. So is it mandatory that the worker needs to be in the same network group?
It can be private IP or public IP. There must be communication between worker and master. That is only criteria. In my case, yes, all my AWS machines are in the same network, and private IP is fine.
So for the manager at this present time, I can even connect with Azure worker, right? Or maybe able to,
Right,
or we have a
right.
different setup for that.
No, it doesn't matter where the machine is. So if it is private IP, then if you want to use private IP, they must be in the same network. Then if they are in different network or in different place in the world, or they are in different cloud provider, you may have to use public IP. So only criteria is that they should be able to connect each other. That's the only thing.
Basil, yeah, it's it seems the worker machines are isolated ones. It communicate only with manager machine. Am I right?
Correct.
Okay.
They are not isolated. They Yeah, we haven't done any outside configurations other than what we have been doing. They are normal AWS machines.
Basil,
Okay.
right now we are using one manager, two workers. But if we use like five managers, like 20 workers, so we need to run all the all the permissions in the all the workers and the managers, right?
Not much changes. In manager, if you want to run multiple manager, there are some kind of load balancing, a few settings to be done. In case of worker, no, it is the same procedure. You will create, if you want one more worker, you will just create one more AWS machine, and then you will run the join command from that machine. That's all. That machine will also join the cluster.
Okay.
Basil, can you please explain me the command which is used last to join the worker to the manager? Kubernetes, the bigger command with
Kubernetes
yeah,
join
yeah,
is that we used. Kubernetes join,
yeah.
and then you specified the master IP address and port, and then some token that is generated inside the manager node.
And
That was
the discovery token CA set hash and SHA 256.
that is mainly for, that is the token itself converted into a hash value, just for the master to verify that it is the right hash, it is the right token. So
Okay.
yeah.
Can more than one manager connect to a single worker?
It can, yes.
Oh,
So you can
Basically,
actually have managers. Yeah.
basically, the admin.config file was created when we installed kubeadm or when we ran kubeadm init command.
When we run
And where did we copy it?
when we run the init command, the certificate got generated for the cluster. So for any cluster that you create in Kubernetes, any cluster that you create in the world, a certificate gets generated. The certificate is used to connect to the cluster.
Okay.
Yeah, it is per cluster. All right, so let us continue. And actually, there is something that I missed. I'm going to talk about that. Okay. All right, so this is the current situation. We have a cluster. So, I will be drawing the machines, not anymore, I think. From now, we will forget about the underlying machines. We worry only about the cluster. Our thought process would, actually, we will stick ourselves to the cluster. A cluster that is running, which has multiple nodes in it. So what will a cluster contain when you deploy your applications into this cluster? What the cluster will contain? It will contain different containers, right? It would contain a shopping cart container. It would contain a prime customer container, and right, you tell Kubernetes to create containers, right? By creating the instructions, you assume you gave some instruction to Kubernetes, and then inside the cluster, now a number of containers got created. And I would never bother where these containers are created. That is not my headache. I would let Kubernetes to make that decision. What I will do is, I will give instruction to Kubernetes. I would create a set of YAML files. Over here, I would write down the instructions. A shopping cart, I want 10 containers to be running. Front end, I want I would just give some instruction to Kubernetes in the form of YAML file. Let me remove all other drawings. They are not no more relevant. I will never talk about individual worker nodes anymore. The truth is that you don't have to talk about them, right? Ultimately, it is once your Kubernetes is up and running, then only thing you will bother about is you tell Kubernetes, how you want your containers to be running. From the shopping cart image, 10 containers need to be created. From the front end, 20 containers need to be created. For the backend software, I want 5 containers to be created. For WordPress, I want 3 containers to be created. For my SQL, I want 25 containers to be created. So you just give this instruction to Kubernetes. The Kubernetes will take these instructions, and then Kubernetes will decide, where the container will be created. Currently you have 2 worker node. Within the 2 worker node, all these containers will get created. So you tell simply Kubernetes, this is what Kubernetes need to do, and Kubernetes will do whatever is necessary. I don't care whether this is running on worker 1 or worker 2. Doesn't matter. All I care is the container running, is my software up and running. That is how it will be. So this way, I would give instruction to Kubernetes, and now I have a Kubernetes cluster. This is my Kubernetes cluster. Which may have, a number of worker node. I don't really care, right? You should never care. I mean, you don't have to care, right? So in our case, there are 2 worker node and 1 manager node. So size of the cluster, we can say 2. I mean, actually it is 3, but 1 node is only dedicated for the management purpose. It will not run the containers. Only the worker node will run the containers. So this is a shopping cart container running in worker 1. This is a prime customer component running in worker 2. This is a payment component running in worker 1. Like that, different containers will get created. Kubernetes will make that decision where container has to be created, all those things. We will let Kubernetes make that decision. This is how Kubernetes will orchestrate your containers inside the cluster. So we never are going to talk about individual worker node anymore. We are going to simply say cluster. So I want all of you to forget about whatever we learned till yesterday. I mean, don't forget. My point is that we will not bother about the worker nodes anymore. We will bother only about the cluster from now, from today. Our intention is to run the containers inside the cluster. The cluster has a number of worker nodes. You don't care 2 or 5 or 10. You don't care. You just give instruction to Kubernetes to create the containers, and Kubernetes will do that. This is the way how Kubernetes will work. The cluster will work. All right. So, guys, take a short break. Sorry, take a short break of 5 minutes. We will Hey guys, welcome back. So it's clear, right? What I said is, these containers are created in one worker node, other worker node, but we don't care where it is. All we care is that do we have enough worker node to run all these containers, right? Otherwise, wherever Kubernetes decide the container to run, it is up to the Kubernetes to decide. Clear, right? So from now, I will be talking about cluster as a whole. I will not be talking about the individual machines. When we talk about deploying our application to the cluster, I would consider cluster as one single entity. Then I would talk in that manner, in that respect. Okay, but before we go there, I'm going to talk a little bit about networking. So assume the current situation is you have a shopping cart, prime customer, and different containers that you created inside this Kubernetes cluster that you created. And again, this shopping cart may be running in container worker one, prime customer may be running in worker two, payment is again running on worker one. It doesn't really matter in which worker node these containers are running. What matters is that they are running inside your cluster. So you will tell Kubernetes how you want your containers to run, and Kubernetes will take those instructions and create those containers accordingly across some worker node or any worker node. All right, and the question here is that how the containers will communicate each other. Every container want to communicate each other, right? Shopping cart want to check with the prime customer component what are the offers available for the prime customers. Then prime customer or some component it want to talk to payment to let the customer choose the payment method and everything. So all the software component, all these microservices, let's call them microservices. It can be, it does not has to be microservice also. It can be any software, but you know that they want to talk to each other, right? That is the basic principle inside the software world. Whenever two communication need to happen between two software component, they will communicate. How they will communicate? Generally through a network. Always, right? The two machines want to communicate each other. It is over a network. Two containers want to communicate each other. It has to be over a network. So there should be somebody who will provide networking, right? In your home, you have your Wi-Fi router. You turn on your Wi-Fi router and it would start providing the network services to you in your home. And all devices in your home can connect to Wi-Fi and get yourself connected. And similarly, inside the Kubernetes cluster, there have to be some networking device. It does not has to be a hardware, it is a software that can act like a networking router or a networking device, assigning IP address to private IP address, of course, private IP address to each and every containers that are getting created. And if every container has an IP, and it doesn't matter in which Docker host or which worker node the container is in, all containers would get an IP. When it comes to Kubernetes, I wouldn't say container, I would use the term pod. I will explain it later. What is the difference between pod and container? For now, just assume pod and containers are same, no differences, right? Assume they are exactly same. So in Kubernetes, it is called pod, not container. They are not exactly same, but almost same. For now, you just assume it's pod. So these are different pod that are running inside different worker nodes, and every pod would get an IP address. And for that, there should be some networking service you have to install on top of Kubernetes. That would actually create a network between the pods. And this network will be, irrespective and independent of the worker nodes. Of course, internally, it know all the worker machine, and it know what are the containers running in each worker. It know the IP address of each and every container, and it had done some some settings inside the machines of the cluster, so that at the end all container get an IP and they can communicate each other. So it is possible. You can install some networking add-on on top of your Kubernetes cluster that will make all your container get an IP and be able to communicate with each other. So that must be done. And if you had noticed, when I was executing the command kubeadmin get nodes, it was telling me not ready. Actually, the worker nodes, even though they are part of the cluster, all the three machines are not ready until you install the networking add-on. And that is exactly what I am going to do. I'm going to install some networking add-on on top of Kubernetes cluster. I already created the cluster, and this is just an add-on which I am installing on top of this cluster. So let's do that. So I'm going to search in Google Kubernetes add-ons, networking add-ons, right? There are a number of add-ons actually. I will go ahead and install any one of them. Installing add-ons, networking and network policy. These are all different add-ons. Flannel is one of them. I'm not an expert in the Kubernetes networking add-ons, but generally, in most of the cases, any networking add-on will work for you, right? Those who are experts in networking can go through this, understand the differences. But in general case, since Kubernetes would let you forget about networking, there is no need for you to become a networking expert, right? It's not needed. So for now, what I will do is I will go with the Flannel. Flannel is a networking add-on for Kubernetes. And okay, something that we didn't do. When we run the kubeadmin init command, we must mention this option if you are planning to use Flannel. This is mandatory, but we didn't. Yesterday, we simply ran the kubeadmin init command. So what I will do is, I think I may have to recreate the cluster because, yeah, I have to delete the cluster and recreate it because this IP address must be specified if you are planning a networking add-on. We didn't do that yesterday when we ran the kubeadmin init command. So what I will do is I will delete the cluster and then I will create it again. Sorry for that. So there's a command. Okay, let me check what is the command to delete a cluster.
Sir, can we able to clone a cluster?
I don't know, but generally you never have to do that. We will talk about it later. Kubeadmin reset is a command to best effort changes made by kubeadmin. Okay. So kubeadmin reset is the command you can execute. It would destroy the cluster. Define update cluster status, remove set number. Right. Right, so I'm just going to run this command kubadmin reset. First, I will run it on the worker nodes, and then I will run it on the manager node. So the command will, first I want to take the worker nodes out of the cluster. So first I will run it on both worker nodes first. On both worker node, I executed this command. And now both worker nodes must be gone. Let me log into the manager and check it. kubectl get nodes. I should see only manager. Oh, they are not gone yet. Okay, now let me run the same command from the manager and see kubadmin reset -f. Kubadmin reset, sorry. Yeah, that .kube file is still there. I'm going to manually delete it. Before that, let me run the command get nodes. Okay, it is not giving me, the cluster is gone. I'm deleting this file also. Now again, I am running the kubadmin init command. Kubadmin init command with this option. What is that? The pod network, right? So I'm going to use this option along with the kubadmin init command. So then what happens is it would, yeah, I should ignore this error, remember. Using this option, I can ignore the num CPU error. I don't have enough CPU, but it's okay, I want to proceed. So then what happens is it would create a cluster, and if you plan to use funnel network, you must use this option at the time of creating the cluster. It's mandatory. It means you must worry about the funnel or the networking add-on at the time of cluster creation, and the networking add-on, once you set it, it cannot be changed.
Basil, like what is that address? Is it mandatory for everyone to use the same address? CVIDR equal to address is there.
Yeah, that is the default address which funnel uses, and I got that IP address information from the funnel documentation. So for every networking add-on, there would be IP block that you would use by default. So in case of funnel, that was it.
Okay.
And now let me copy this certificate into .kube config file. It must be done. And I did that, and now I should be able to run the kubectl get nodes command, and I can see currently there is only one machine, and that is your manager node, and this is the command that your worker node can execute if they want to join the cluster. So before I do that, first of all, let me install Flannel. So go to the Flannel website, documentation of Flannel, and this is the command you can execute in order to install Flannel. kubectl apply. For kubectl command to work, first you should copy the certificate. I already copied the certificate, and then this is one single command you can execute that will do the job. That will install Flannel. I think I think we have to pick the second command. For Kubernetes v6 and v515 CNI plugin version 0.57 or later. Okay, let me take the latest one. I don't know. I will go ahead and pick the latest one of Flannel. Okay, this is the command. This is the command. You must use. Okay, I will go ahead and run this command. And then it will install Flannel networking add-on. And this time you run the command get nodes again. Currently it is saying not ready. Soon it would become in ready state. Yes, now it is ready state. So until you install the networking add-on, your manager or worker node would not be able to work, right? So now you have the manager. Now let me add the worker nodes. This is the command I can execute on both worker nodes to join the cluster. I have to run the command, same command in both worker nodes. Both the worker nodes got disconnected. Let me log in again. So go to the worker one and log into both machines, worker one and worker two. This is worker one, and now let me go to worker two. And on both worker nodes, I'm going to execute this join command. Then the worker nodes will also join the cluster. So I just deleted and recreated the cluster once again because the networking add-on settings had to be enabled. Now you run the command get nodes. You can see two more worker nodes came, joined the cluster. Soon they would become ready, and now they are already in ready state. All the three machines are in ready state. We are done. So a networking add-on must be installed inside a Kubernetes cluster to form a pod network. A network, the pods can communicate each other. This is not a real network. This is not something provided by AWS. This is not something provided by your local internet provider. This is a networking add-on, a software network, right? You can say it's an SDN, software defined network, that would generate a network like environment over which your pods can communicate each other. Every pod would get one private IP. As soon as they created, they would get an IP and they can communicate. So this is how the communication works inside the Kubernetes cluster, the container communication. This is how it happens in the Kubernetes cluster. All right. So any question on this?
So every command should have to run in manager node, no?
Every command, every change that you want to do on the Kubernetes cluster, kubectl is the command. Yes, from the manager we will run it.
So
And
we are not applying any commands to the cluster worker machines by individually, no?
No,
Okay.
never. We never do that. All these instructions are cluster wide, and sometimes you bother which container a node is running on. I mean, which node container is running on. Most of the time, you will never bother. So it is basically up to Kubernetes. Once Kubernetes have your instructions, it will create the containers in the cluster. That's what it will be. You will not bother when you work inside Kubernetes or when you run your application in Kubernetes. You will not bother about individual worker node, but the whole cluster.
If I need add additional machine to the worker node, then same procedure should have to follow me, no?
You will run the kubadmin join command
Okay. Okay, got it.
on a new machine, and that machine join the cluster. So adding or removing the machine is probably your responsibility. Once it is added, then you don't, it is not like you would stop worrying about the machine. You would completely focus on your YAML files and your Kubernetes application status, deployment status.
Okay.
Basil? Hi, Basil.
Yes, yes.
Hello. Yeah, actually, the thing is that you have a like private IP of AWS like 172 starting from. So first thing is that you
Now we lost your voice. Can you come again?
IP like different from our actual private IP of instance, we can use the same IP, port network.
A pod network is a different software network that we have just created ourselves in the Kubernetes cluster. Sorry, I think I might have missed your question.
No, the thing is that you have mentioned like pod network 10 like that, but we have an instance IP like 172. So as the like real IP of private is different, and Kubernetes machines, nodes and master all are connected with like a pod network in a admin init command, which you secondly run. I mentioned a pod CIDR network 10. So I
Right,
don't
right,
understand that the thing why you use 10 different from a EC2 instance IP CIDR.
right, right. No, and I got your question. So what I'm trying to explain here is that how the pod will communicate each other. Right, that is our problem. We don't have any other problem. The AWS machines are able to communicate each other. We are happy about it. And even if one is AWS machine, one is Azure machine, they will be able to communicate each other. We are not worrying about the worker nodes in the cluster. We are worrying about when you create these containers or pods inside those worker nodes. Maybe shopping cart is a pod running in the worker one node. Prime customer is another pod running in worker two, and you cannot call them worker 2 or worker 1. They are pods inside worker 1 or worker 2, how they will communicate each other. Or maybe you have payment that is also running in worker 2. So this is one pod in worker 2, this is second pod in worker 2. They also want to communicate each other. So that is why we need a separate network for communication between the pods. When I say pods, assume containers. For communication between containers, you need our own network. Kubernetes should create its own, a software-defined network for internal pod communication. So the funnel or whatever networking add-on in Kubernetes we are talking about, it is only for the communication between pods. It will do something. It may be doing something. It is using
My thing is
the
that
underlying. No, let me finish this. It may be using some
STEM and
IP
different CIS.
tables or kernel settings of what are already available on the underlying Linux operating system. The worker nodes are running Linux operating system. Manager is running Linux operating system. It has a kernel. It has the networking features. It has IP tables. It has some different forwarding. So basically, you Funnel will let you forget about all that. Funnel will be using all that in the background to establish such kind of communication between the pods, and that is what you bother about.
Okay.
It's making sense, right? I mean, right? So do you need to be a Linux admin or networking expert to work on Kubernetes cluster? No. I mean, that is the whole point I am coming into. Kubernetes is a something that works in as a platform as a service mode. Platform as a service means it will let you forget about the underlying infrastructure and let you focus on your applications. And Kubernetes is a tool that does that. And we will not be digging too much how Kubernetes works, how Kubernetes is developed, how you can develop, contribute to Kubernetes. Those are not, we won't be focusing too much on those topics. We will stick to our topics. Yeah, anyone else, any questions?
Still, it's mandatory to we need to use a separate, but the thing is that like we can't use the same CIDR like a EC2 instance, no, right? 172 or something
No.
for
No.
because when we launch a container in Docker, okay, so Docker images container gets a IP like same as our EC2 host has. So from that IP, they not communicate with each other, or like all EC2 have a same IP like 172 or in same network. So is it not feasible to use that IP?
That IP was also not AWS IP. When we run the Docker run command also, we got an IP. That was actually a software IP. It was not AWS IP. Okay, right.
Okay.
So so this is a software networking that we have to establish because we want our application to talk each other. We want a shopping cart to talk to prime customer, and how shopping cart will talk to prime customer through a network using IP address. So you don't have to really worry about how the networking will happen when shopping cart is running in one container and prime customer is running in another worker node. This is in another worker node. How these containers will communicate each other. You don't have to worry. You have Flannel. Flannel will worry about it. Frontal will worry about it, and it would give you an IP address for every ports, and Frontal tells you that using this IP, your containers or your ports can communicate each other, and that is what matters.
So
All right.
Bisal, what I understand is funnel is like an internal algorithm which will manage everything regarding this software-defined network or IP adjustment, correct? To
Right.
communicate each other.
That's correct. That's correct. Frontal takes
Uh,
care of network connections between ports.
okay. Any scenario where we will face or we can face a networking issue? Of course,
No,
funnel is there, but anything else like any practical
no,
scenario? No. Okay.
no.
Okay. Thank you.
Okay, okay. So, right now we have our cluster ready, and any I would also request all of you to keep any Linux or networking related questions. Let's keep them in the chat. We will discuss them at the end. Otherwise, it might affect our continuity. It's already a complex topic, right? So we will focus only on the platform as service Kubernetes feature. All right. So the next thing, now it is time to start giving instructions to Kubernetes. We are going to instruct Kubernetes how you want to do. So let's we will take only WordPress and MySQL for now. So I want to do this. I want to tell my Kubernetes cluster that I want to create 3 WordPress containers. WordPress 1, WordPress 2, WordPress 3. So like that, it would give you 3 WordPress containers, and I want to create 1 MySQL containers. Not I want to create total 4 containers inside the Kubernetes cluster that I just created. This is what I am going to do. So now I am going to give instruction to Kubernetes that I want to run WordPress and MySQL containers inside the cluster. I want 3 WordPress containers to be running inside the cluster and 1 MySQL container to be running inside the cluster, and you will be writing YAML files for this. Different YAML file you will create, and this YAML file you will write the instructions inside those YAML file, how you want the WordPress to be deployed, how you want WordPress containers to be created, which image do you want to use. So to create containers, you definitely have to use a Docker image, right? You must have a Docker image. For now, we will use the official WordPress image. So you should have a WordPress image, and you must also have a MySQL image. Then you will give instruction to Kubernetes to take this WordPress image and this MySQL image. From this WordPress image, create 3 WordPress containers. All the 3 containers will look exactly same. And from this MySQL image, create 1 container. And then Kubernetes can decide where it want to create. In our cluster, we have 2 worker node. So let Kubernetes decide in which worker node it want the container to be created. I don't care. So I'm going to write 2 YAML file, 1 YAML file for deploying WordPress and 1 YAML file for deploying MySQL. That is what my plan is. I'm going to do this. So to do that, actually you can search in Google Kubernetes deployment. There is something called Kubernetes deployment. You can search in Google for Kubernetes deployment. then you will get a sample YAML file, rather than writing everything from scratch, which I will show you later how to write everything from scratch. But generally, you will never do that. You want to create a deployment, you will search in Google for Kubernetes deployment, and then you will get one sample YAML file. You will simply copy this YAML file inside the machine where you have kubectl installed. So go to that manager machine, that is where we have set up kubectl. So in the manager machine, come on, I got disconnected. Looks like I need to log in again. From now, I am never going to log into the worker nodes also, right? It would be like I never have to log into worker node. I am never going to manage the worker node. I want to run the kubectl command, that is with the I need to log into manager. Otherwise, I don't want to log into any machines in the Kubernetes cluster. So kubectl is the command you can always execute whenever you want to make any updates, or you want to write something, or you want to read something to Kubernetes. Kubectl is the command. So in my case, what I am doing is I want the YAML files to be created. I'm just creating a folder called WordPress, and inside the WordPress folder, I create another folder called Kubernetes manifest or something, or maybe you can directly create the YAML file here. So I'm creating a YAML file called WordPress deployment dot YAML. This is a text file, right? You can edit the file using nano editor. And like I said, I'm not writing everything from scratch. I simply go to the Kubernetes website and copy a sample YAML file from there. And I'm simply going to specify the replicas here under the, over here you need to mention what you are creating. You are creating a deployment. I will explain in detail what is a deployment and what it will do later. So right now we are creating a deployment. What deployment are we creating? We are creating a WordPress deployment. So you can give some appropriate name here. I'm creating a WordPress deployment, and here you can give some label. What is the application? You can give. It's up to you whether you want to give it or not. That is also up to you. And you mention the number of replicas. How many pod you want to run for WordPress? How many containers you want to run for WordPress? I want total 3 containers to be running. This is where you mention the number of replicas or number of pods. And match labels, I'm going to set it to WordPress. I will explain this later. Here also label in, I'm putting, again, I'll explain it later. So over here, you need to mention the details. Under this session, you have to mention the details of the container that you are creating. What is the port your container is listening on? In our case, it is empty. It is, sorry, it's 80. WordPress runs Apache and it listens on 80. So nothing to change there. You can give some name to the container, which is even though optional. It's a good idea to give some name. So I give the name WordPress itself. And over here, I need to mention what is the Docker image that you want to use. Got it? This is where you would mention the Docker image. You tell Kubernetes that it is the official WordPress Docker image. You go to hub.docker.com. What is the name of WordPress official image? It is WordPress, right? So that is the name you have to specify. The name of the image in hub.docker.com. In case of WordPress, the name is WordPress. So pull the image from hub.docker.com, look for the WordPress image. And how many containers to create? 3 containers to create. So these are instructions you are giving to Kubernetes. Okay. These are instructions you are giving to Kubernetes. What I also want to do is I want to pass some environmental variable. Don't you do that when we use the docker run command to establish the communication from WordPress container to the MySQL container? What did we do? Remember, during the docker run command, let me show you that once again. First time when we created WordPress, right? At that time, sorry, when we created WordPress for the first time as containers, we created a WordPress container, we created a MySQL container, and at the time of creating this container, what did you do? You passed environmental variable. That environmental variable tells the MySQL container what is the name of the database that will be created, what is the username, what is the password, etc. And then similarly, the WordPress container will tell, when you use the docker run command to create a WordPress container, you pass some environmental variable to tell WordPress what is the content of the wp-config.php file. Environmental variable at the time of container creation. We have seen that in the docker run command. Now we will see how in Kubernetes you can pass the environmental variable. The same environmental variable, right? You go to hub.docker.com, take a look at the documentation of MySQL and WordPress. Right now I am creating the WordPress YAML file. So first of all, take a look at the WordPress image in hub.docker.com. So I am here in hub.docker.com. I open the WordPress image. I take a look what are the environmental variable. You have to specify the database host, the IP address of the MySQL container. So I'm going to mention some environmental variable. This is how you do it. Under container session, you create a new parameter called env. And over here, I'm going to mention the environmental variable. This is the format, name of the environmental variable. This is the name of the variable. Then you can specify the value. I'm going to mention, I'm supposed to put the IP address of the database container, right? Assume this is the IP address of database container. This is what I put. I'm not doing that. I'm just simply putting database or MySQL service. I'm putting some name instead of IP. I will explain this later. Database user, WP user, assume this is the username. We have not created the database or user yet, but this is probably what I want to create later. The password, again, I'm going to set something, some value. Database name. No, I'm planning to create a database with name WPDB. So, I'm just telling at the time of WordPress container creation, I am passing these values. These are the values that will be updated in the wp-config.php file of my WordPress container. So we can do this. Maybe, okay. Actually, our syntax was also correct, but just wanted to keep the same format. I talk about the YAML file syntax in a bit. So right now I created instructions for WordPress deployment. I mentioned which image to use, what are the environmental variable to pass. I know about this particular Docker image. I know what these variables will do if I pass them. Whatever values I pass would be updated in the wp-config.php file of my containers, right? In my containers, in all the WordPress containers that is getting created, in the wp-config.php file, it will store that data, store these credentials, whatever I am passing. So yeah, that is done. That's all. I'm going to save this file. And how many container to create also I mentioned here. Replica is equal to 3. I gave some name for the deployment. So all done. Similarly, I want to now create the MySQL container. I want to create only one. So what I am going to do is, I will make a copy of this file. No, I don't want to write everything from scratch. I will just copy the WordPress YAML file and into this file. Then I will edit this file because the syntax is same, only some values need to be changed. So right now I am going to create a MySQL deployment. To give it some appropriate name, I'm going to create a MySQL deployment, and the name of the app is also MySQL. And I want to create only one container, right? In case of MySQL, I want only one container, not 3. So replicas I put 1, and the name I give MySQL. We will talk about labels later. So over here, you have to give some name to the container. Not mandatory, but good to have. MySQL is the name of the container you want to give. Then here you can mention the name of the image that you want to use. It's MySQL 5.7. I want to take this image. This is an official MySQL image available on hub.docker.com. I am asking Kubernetes to take that image from hub.docker.com and deploy it. And then I have to specify the MySQL root password. Remember, if you go to hub.docker.com and go to MySQL, there are a number of environmental variables that are supported. Go and check those variable names. MySQL root password. So here I'm going to mention a variable called MySQL root password, and I'm putting some value here. Let's say DevOps 1 or something. This is a mandatory variable. I must specify something. Then I need to mention the database name, username, and password. So MySQL user I mentioned here. Then I need to mention the MySQL password. There is another variable here. And then we have the name of the database name. I'm going to mention that here. All right, so I did that. So now I had wrote the instruction to create the MySQL deployment also. Okay, great. So I created 2 files. This file has instruction to create the WordPress deployment. This file has instructions to create the MySQL deployment. So I just prepared these instructions in 2 YAML file. I created a total of 2 YAML file, one for WordPress, one for MySQL. And now I am going to ask my Kubernetes to apply these instructions in the cluster. That is what you always do when you work on Kubernetes. That is your responsibility. You prepare the instructions, give the instruction to Kubernetes. This instruction is also called the decide state of the cluster. This is what I want the state to be, right? This is called decide state of the cluster. This is how I want my cluster to look like, or my application to look like. Kubernetes will get this decide state from you, and bring the cluster to that state, whatever you instructed. So I'm going to execute. It's a single command you have to always run once you prepare the instructions. It is a single command. So you want to create the MySQL deployment, run the command kubectl apply -f, then MySQL deployment.yaml. So this is the way. We have some syntax problem, line 23. There is some syntax problem in line 23. What is it? I think I made some syntax error. 1 second. Environmental variable. Now let us see how to define environmental variable. That is the only modification we did in the YAML. I assume I made some syntax problem. env colon, then name value, right? Okay, there is no syntax error. There is no syntax error, right? Anyone see anything?
Basically, the YAML file does not support tabs, I guess. They need spaces.
Oh, right, true. So I was using a tab. Yeah, good observation. Yeah. I was actually using a tab space. It should be normal spaces in YAML. That is correct. That is why it failed. YAML file don't support tab space. It has to be normal spaces. Okay, cool. And you have to do the same change in WordPress also. All right, so once you prepare all the instruction, you can simply run one command. It will apply this YAML file to the Kubernetes cluster, or in other words, you can say this command will instruct Kubernetes to read this YAML file and follow those instructions. So this YAML file is all about creating a MySQL deployment with one MySQL pod. Run the command. That's it. You created a MySQL deployment, and as a result of this deployment, one container get created, one pod get created in the cluster, the MySQL pod. Okay, so now you have created a MySQL pod. Basically what you did is you created a deployment. That is what you created. You created a MySQL deployment. MySQL deployment. MySQL deployment got created in your Kubernetes cluster. And as a result, this deployment had created one container, because you mentioned replicas equal to 1. It will create only one container. This is the current scenario. And I'm going to do this command now, kubectl apply WordPress deployment. Now I am deploying vectors to the cluster. What will happen? As per this YAML file, I want to create a vectors deployment. So what happens is a vectors deployment get created in the cluster. A vectors deployment got created in the cluster, and what this vectors deployment will do, it will create 3 replicas. It would basically create 3 vectors containers. That's what it will do. This is vectors 1, vectors 2, and vectors 3. Total 3 containers would get created by your vectors deployment. This is how it works. Got it? So your vectors deployment is created, and it had created total 3 containers. Your MySQL deployment is created, which created 1 container. So this is how it works. Okay, great. So you want to see how many deployments are created, how many containers are created. You can use the same kubectl command. Kubectl command has different way of running. Kubectl get deployments is a command you can execute. Then you can see all the deployments you created so far. There is 1 MySQL deployment and 1 vectors deployment. Right? There is 1 MySQL deployment. There is 1 vectors deployment. The instruction was to create 2 deployments in the Kubernetes cluster, hence it created it. That was the instructions that we had given. Create a MySQL deployment and create a vectors deployment. And you know that this deployment would create containers, right? MySQL deployment would create MySQL container 1 because you mentioned replica equal to 1. Here it would be 3 because you mentioned replica equal to 3. So total 3 vectors containers. You can see it here itself. 3 out of 3. They are all up and running. All containers, all pods. I should be using the word pod. So all pods are up and running for vectors. All pods are up and running for MySQL. You want to see the list of pods. There's a command called kubectl get pods. Get deployment to see the list of deployment. Get pods to see the list of pods. I have total 4 pods running. So remember, we didn't directly create the pod. What we did is we created the deployment. It was the deployment who created the pods. There is a difference. There's a difference. I wrote the YAML file not to directly create 4 pods. That was not the idea. My idea was that create 2 deployment who is a controller. These are controllers in Kubernetes, and these deployment have some settings, right? 1 replica, it should be taken from a SQL image, right? All the instructions, so deployment is what create your containers, your pods. So I created the deployment using these instructions, these YAML files. I'm sorry we got late a bit, but yeah, you have the idea now.
I have one question, Basil. Can I ask it?
Yes, Samir.
Yeah, currently you are creating 3 WordPress containers. So why you are creating like that? That's my question. Is that 3 instances or what?
Yeah, we want 3 containers. Assume I am getting too much load on my infrastructure and 1 container is not enough. I may want 3 or maybe 30 or maybe 100. It would be based on my requirement, my infrastructure requirement. How many containers do I need? So I might need more than 1, may
So
or may not.
if one instance, if one container will goes to down, then others can communicate with this
Uh,
infrastructure, no?
yes, actually yes, but we haven't discussed that yet. That is our next topic. Yes, actually, Kubernetes can handle that.
Okay, can you explain flannel little bit briefly?
Yeah,
Funnel's task.
Funnel task is basically, right now what we created is a Kubernetes cluster, right? And to create this cluster, we had to use machines. We used 3 AWS machines, or maybe, I used AWS machine. It can be any machine, right? So you use some machine, you created some machine, and all these machines are part of your cluster. You have multiple nodes in the cluster, and all these machines will have some networking settings, their own operating system, and all these things. But when we create our containers, the containers are independent of the machine, right? Is it clear? In the first class when we learned Docker, we created a AWS machine, we made it a Docker host, then we created a container. The container had its own IP. So container is more like a independent unit. It has its own IP, it runs its own software. It want to talk to other containers, then it should be able to. So that is how it should be. In the container world, every container should be independent. Every container must have everything it should have, right? I mean, what that means is WordPress container. Take the example of your WordPress container. WordPress container you create, then it will run Apache, it will run WordPress, and it will have everything. It will have Apache running in it, and yes, it has an IP also. If somebody want to connect to the container, they can connect to the container because the container has an IP. So container has to be independent. In Kubernetes, we use the term pod. So I would say pods have to be independent. They all must have their own IP. But remember, think about a Kubernetes cluster that has too many worker nodes, too many machines. And in every machine, you have total, in our case, we created 4 containers, and 4 containers are running on the entire Kubernetes cluster. Our cluster has only 2 Docker hosts, right? 2 nodes. So in 2 nodes, we created 4 containers. Maybe in real time, you have total, 1,000 machines, and in 1,000 machines, you are creating 2,000 containers. It is quite possible. At the end, what you bother about are containers, and you know that the containers has to be independent. So is there any networking that will connect the containers together? There must be, right? There must be a network. By default, there is no such network. I mean, your AWS, one of the machine is from AWS, one of the machine is from Azure. Yes, those machines can communicate each other, but can your containers connect each other? No. For container communication or for pod communication, we should develop our own network, and creating such a network is not an easy job, because this network have hundreds or thousands of machines and a number of containers running in each machines, and our network should connect only the containers, not the Docker host or not the worker nodes, only the containers. So designing such a network is very difficult. You have to create such a network, it is something like years of work. What Kubernetes does is it allows you to install some networking add-on, and these networking add-ons such as Funnel, it is capable to work inside the Kubernetes cluster. It understands you have a 2 worker node or you have 200 worker node. It understands all the worker node. It understands the networking of the worker node. It will finally, with all this information it has, it would create a software network at the end that will connect only the containers together. Doesn't matter in which Docker host container is running. At the end, every container get an IP, every container become independent, every container become capable to connect to any container across any cluster. I mean, across the entire cluster. Within the cluster, doesn't matter which Docker host the container is in, you don't have to worry about it. You have got a network, and this network look like your home network, your home Wi-Fi that will connect to all your home devices together. In your home, you may have different type of devices, or whatever. Your Wi-Fi router, what it does is it will connect all your mobile phone, laptops, desktops, everything got connected. Your CCTV, right? Whatever networking devices do you have in your home, it connects them together. Same way, Flannel connects all the pods together within the Kubernetes cluster. Whatever new pods that are coming, or whatever existing pods are there, all pods in the cluster and all the new pods that you are going to create, and all the pods that are presently running, they all get an IP. They all can communicate each other, and that is what you need. You want the ability for individual pods to become independent and be able to connect to each other. And to do that, you need such kind of a networking software and such kind of a networking system. That was the Flannel's responsibility. Give us such an isolated network that will connect pods. Does that make sense, or it became more complicated?
Yeah, sir, can you upload videos like today's and yesterday's video?
Yesterday's video is already uploaded. Actually, initially I uploaded it with a wrong name. Then yesterday evening I corrected it. So yeah, today's video I'll upload.
Basil, like, can't we use all the services? I mean, all the services in the same manner, include all the services.
Soumya, I'm sorry, can you be a bit louder? Actually, from
Yeah,
construction.
like, my question is, I mean, can't we include all the services in the same ML file? Like, instead of writing different ML files for the WordPress and MySQL,
It's possible.
yeah.
You can put
Okay,
all
okay.
the content in one file. That is also possible.
Uh-huh.
For the easiness, I created separate files.
Oh, okay. So, and also another question is, like, if we replicate the MySQL container, so the data become inconsistent, right? So how it will work?
Uh, that is why we didn't create multiple database container.
So, like, if we want to replicate the database, so
There
how?
are ways to do that. In MySQL, for every database technologies, there are ways to do that. We will cover that at some point in our training itself. And that is part
Mhm.
of your project, Kubernetes project. So it's not up to
Oh.
Kubernetes, but every database technologies can work in a cluster mode. And yes, Kubernetes can support that.
Okay, like, and also another question, like, we have created four containers, three for WordPress and one for MySQL, right? And how the manager node know, like, uh, these four containers will get deployed in which worker nodes?
In the two worker node, what we have, if you want to know, there's a command to find out. I don't know in which worker node currently they are deployed, because I didn't bother to know. But yeah,
Hmm.
along with the get ports command, if you use -o wide, currently my session got disconnected. I'm not able to type. The command will be
Hmm.
obctl get ports -o wide. If you run this command, in the output, it will also show you the worker name, in which worker node it was created. That will also display here.
Okay. Okay. Thank you, Miss.
Okay, Basil. So can't we see the file structure in this uh, containers and other stuffs? Can we see the file structure using any FTP connection?
We don't do that. We won't do. Yeah, it is possible. I think we already discussed that. It is possible in Kubernetes also. It's all about what service you want to run inside the container. If you are running an FTP service in the container, then yes, it can be connected from outside through FTP. And one thing I want all of you to forget, especially those who are from the Linux background, you are never going to log into any of these containers. Technically, it is possible, though it is possible. You are never going to directly make any modification to any container that run in your Kubernetes cluster. That is not the way of working inside a Kubernetes cluster. You develop the images. You develop the images with all your application in it. Then Kubernetes will take the image and deploy them. Once your containers are created, you, neither whether you are the DevOps guy, you are the operation guy, you are the one who manages the server, you are the developer, whoever you are, you won't directly modify a container. If there is a problem, you will work on the image, fix the problem, develop a new image, then that is the way you will be working in the container world. So you will get a clear idea as we move on.
If there is something happened in Kubernetes, so it means some kind of generate any errors on any bug. So can we see the error log through the
Yes,
Kubernetes?
yes, you can. You can see the logs. There's a command called kubectl logs, using which you can see the logs. Yes.
Okay.
Okay. Cool. So yeah, watch today's video once again. Today's was a very important class. So watch. I will try to upload it as soon as possible, as soon as it converted. So yeah, cool.
Basil, can you please provide AWS G Drive access also?
AWS don't have Google Drive. It is in portal, and portal is currently down. So we have to wait until the portal come back. I hope I can fix it today. Just I was very busy in last 2 days, so I couldn't look into it. Today I will try, I will hopefully it will be fixed. Okay, yeah, bye everyone. Take care. See you tomorrow.
Okay. Thanks, Basil. Bye.
Thank you, Basil.
Nice.